Luca Oliva. It's already the 8th ArthroPub lecture, but to avoid any confusion, we had this year another one delivered by Francesca Biaccioli. It was a postponed lecture from last year. So before I want to introduce to you our lecturer, let me tell you some information on the fact why this lecture series is called Pub Lecture. It is in remembrance of Arthur Pub, who was born in Switzerland in 1941, had to flee to the United States, studied with Cassirer and Ernest Nagel, made his PhD there in New York. And afterwards, he came in close contact with analytic philosophers there, for instance, Sellars, Black, Quine, but also Feigl, Hempel, and Carnap. In 1953 and 54, he returned to Europe as a Fulbright guest professor to the University of Vienna and joined the circle around Viktor Kraft, which is known now as Third Vienna Circle. And here he lectured and researched and published a most important book called Analytische Erkenntnistheorie, kritische Übersicht über neueste Forschung in USA und England, 55, with the help of his assistant Paul Feyerabend. And this book was dedicated to the vanished Vienna Circle here in Vienna. It reads dem Wiener Kreis zum Andenken und zur Wiederbelebung. After his return to the United States, Pub took over a chair at Yale, and he published seminal books on analytic philosophy. He can be seen as a pioneer for analytic philosophy. Let me mention only the books: The A Priori in Physical Theory, Elements of Analytic Philosophy, Semantics and Necessary Truth, or An Introduction to the Philosophy of Science, posthumously 62. He died too early because of a disease, serious kidney disease, and we were very happy that the Pub family donated his scientific papers and library to the Institute Vienna Circle, now Vienna Circle Society, as a sort of symbolic coming back to his origins. And for all those who are interested, there's a catalogue of these archives together with his private scientific library. Now, these pub lectures were started in 2018, taken over by David Stump, Scott Soames, Sanford Shee, Cheryl Missak, James Glacke, Paola Cantu, Francesca Biaccioli, and this year it's Luca Oliva. We are happy that he accepted our invitation. He is currently a tenure-track assistant professor at the University of Houston. At the same time, director of liberal studies, and his research is in the field of epistemology and philosophy of mathematics. He has published a lot of articles on analytic Kantianism, the a priori in logical empiricism, including Wittgenstein, or on Rickard's abstract objects and normativity. Oliva, sorry, it is my mistake, teaches theories of knowledge and truth as well as ethics. And he was also guest professor at European universities, also in Vienna and at the Institute Vienna Circle. He lectured in the last years. So, which is known to the audience, he's co-organizing this lecture series, Reconstructing Carnap, which, by the way, had another presentation yesterday. And he initiated the Ethics and Normativity Seminar at the University of Houston. I think that's good enough to tell who he is, and we are looking forward to his lecture, entitled Kinds of A Priori. Thank you.
Okay, so thank you very much for this kind invitation. So I want to thank Georg Schimmer from the Institute Vienna Circle, and obviously Friedrich Stadler from the Gesellschaft Vienna Circle. And thank you everybody for being here today. It's a very hot day and in the middle of the semester for you. So thank you so much. So my talk is on kinds of a priori, and we'll focus on one of the three a priori of Papp. In 1944, Papp distinguishes three kinds of a priori, which imply three kinds of necessity. My talk will be mostly about the relation between necessity and analyticity, simply because for Papp, a priori entails both. So the three kinds of a priori that Papp describes are the formal or analytic a priori, which implies formal or logical necessity, which characterizes logical truth, either conceived as tautologies or truth of reason, depending who is reading them. And the second kind of a priori, which has been mostly discussed by the work of Stamp, is on the functional a priori, which implies functional necessities, mostly the a priori for sciences or scientific knowledge. And then a material a priori, which implies psychological necessity, although the representatives of this kind of a priori or this kind of necessity rejects this idea of psychologism. The main cases are Husserl's phenomenology and Meinong's Gegenstandstheorie. theory. So we will focus on, as I told you, the formal a priori and the kind of necessity which is a sort of formal or logical necessity. And I gather so the arguments of Papp around two different topics, so the analyticity and necessity, and instances of non-analytic necessity. So Papp's style is pretty much analytic in the sense that he really analyzes and argues for details, and he doesn't build actually a theory that somehow is answering some questions, and he recognizes that in his works, and he is very outspoken about this kind of method. So I teach a course which is called the Theories of Knowledge, or Knowledge and Methods, and I'm pretty much an analytic guy, so I use Chisholm. And to show the relevance of Papp, I want to show the chapter of Roderick Chisholm in his wonderful work, Theory of Knowledge. This is chapter 4, devoted to the a priori. And the a priori of Chisholm starts with a quotation from Leibniz, which is central to Papp's investigation. There are two kinds of truth. I think everybody knows this quotation, but there are two kinds of truths, those of reasoning and those of fact. The truths of reasoning are necessary, and their opposite is impossible. Those of fact, however, are contingent, and their opposite is possible. When a truth is necessary, we can find the reason by analysis, resolving the truth into simpler ideas, and simpler truths until we reach those that are primary. That's from the Monadology of Leibniz. For Leibniz, all truth derives from the analysis of identities. Those components or notions, which usually are the S term and the P term, are related by inclusion or containment, which is also the main way in which Kant understands this relationship. Otherwise, there would be a truth that couldn't be proved a priori, that is a truth that couldn't be resolved into identities, contrary to the nature of truth, which is always an explicit or implicit identity for Leibniz. In true propositions, indeed, the predicate or consequent is always in the subject or antecedent from primary truths. In identities, the connection of the predicate with the subject, its inclusion in the subject, is explicit. In all other true propositions, it is implicit, as Kant actually says, and has to be shown through the analysis of notions. So here are examples of first truths that are the one that assert something of themselves or deny something of their opposite. And the truths are quite simple. A is A is not non-A. If it is true that A is B, then it is false that A isn't B. That is false that A is not B. Kant, as I anticipated, defines analyticity consequently. So he said that an analytic judgment was one in which predicate B belonged to the subject A as something which was covertly contained in the concept of A. He contrasted analytic with synthetic judgments in which the predicate B lay outside the subject A, although it did stand in connection with it. Analytic judgments, he explained, had nothing through the predicate to the concept of the subject, but merely break it up into those constituent concepts that have all along been taught in it, although confusedly. So synthetic judgments for Kant, on the other hand, add to the concept of the subject, a predicate which has not been in any way taught in it, and which no analysis could possibly extract from it. So Kant gives the example, all bodies are extended as an instance of analytic judgments on the ground that the required predicate can be extracted from the concept of body in accordance with the principle of non-contradiction or principle of contradiction. As an example of a synthetic judgment, Kant gives all bodies are heavy. I think these are somehow two references, Leibniz and Kant, which are very common to most of the people who work on the a priori or analytic sentences. Accordingly, for Kant, the predicate connection established by analytic judgments is taught through identity that resembles what Leibniz said before. The main, somehow, glue of this, or a main explanation for understanding whether a judgment or a proposition is analytic or synthetic is about containment. Containment is not the only criterion that Kant uses, because he also introduces this idea of awareness. So he said that analysis awakens our awareness of the manifold we always think in the subject term. So it surprisingly bears a psychological connotation, so to speak. And the psychological connotation, by the way, is what Pape uses to emphasize the material a priori. We will see that later on. On the contrary, synthetic propositions show no containment whatsoever. Here's a quotation from Anderson. So the relation between the two terms, concept or classes, is possible in two ways, namely as containment for analytic judgments and connection without containment for synthetic judgments. What how Pape sees these references, or how he understands these propositions. Before that, sorry, there is another part on Kant. Kant also discusses a third kind of judgment, the synthetic a priori. Here the help from experience is entirely lost. This is a very controversial, is the controversial kind of judgment that is so puzzling for analytic philosophers and logical empiricists in the same way. How do we combine concept A with concept B lying outside A? How can we justify their synthesis? Kant's solution, I'm not going to deep into this because it will require, obviously, a series of lectures to describe the synthetic a priori in Kant, but I think this is the gist of Kant's synthetic a priori judgment. Kant's solution involves the basics of his theory of cognition. Okay, so if you want to understand the synthetic a priori in Kant, you need to understand all the premises that support his theory of cognition, which starts with an affection that modifies our sensibility. If the perceived alteration of senses is altogether ignored, sensible intuition and the spatiotemporal field where it occurs still remain. This immediate and individual intuition stands for a part of that spatiotemporal whole. Since it carries nothing empirical, it provides pure content to which concepts may apply. So the same operation, synthesizing sensation-bearing, that is empirical intuitions of any object, empirical object like an apple, can also unify them when they are still sensation-free, namely pure or before all experience. The conceptual, that is categorical, synthesis of pure intuitions forms the semantic terms or classes for judgments, which is claims or cognitions. Those synthetic operations on terms are entirely possible a priori. So this is the gist of synthetic a priori in Kant. I'm not talking about now the very interesting development in Kant's philosophy of mathematics, where pure intuitions are compared with free variables. I'm talking about the development in Pose's collection presented by Charles Parson, Jaakko Intikka, including Michael Friedman, Beth, that work on Beth's analysis of Kant's geometry. So, I was saying, how does Pape see these references? Pape's philosophy is in between, so to speak, logical empiricism and analytic philosophy. And he is critical of both, actually. In his epistemological writing, the term a priori for Kant primarily designates two properties: existential and cognitive conditions of every object, and a modal propositions about necessity. This is how logical empiricists somehow, very roughly speaking, understand the Kantian a priori. So with these two characteristics, consistently, they analyze the central properties, constitution, and apodicticity that characterize the Kantian notion of a priori. Like Kant, empiricists eschew metaphysics on the ground that every factual proposition must refer to sense experience. As Hume claims, no general proposition, whose validity is subject to the test of actual experience, can ever be logically certain. Its verification always allows for computation at some future point. Therefore, a law can only be substantiated in n minus one cases, offering no logical guarantee of confirmation in the nth case as well, regardless of how large n may be. If this is correct, propositions referring to matter of fact can never be necessarily or universally true. Ayer, for instance, who is in this case one of the best, I think, examples of this criticism of Kant synthetic a priori, extends this conclusion to all general propositions with factual content. They can at best be probable hypotheses, since none of them ever achieves logical certainty. Nevertheless, these premises fail to account for the knowledge of necessary truths. Why? Because the principle of logic and mathematics are true universally. That's a big problem, simply because we never allow them to be anything else, would add Ayer. And Pep would agree with that. The reason for this is that we cannot abandon them without contradicting ourselves, without sinning against the rules which govern the use of language, and so making our utterances self-stultifying. In other words, the truths of logic and mathematics are analytic propositions or tautologies. So that's the conclusion somehow of logical empiricism, and is the starting point of Arthur Pape's analysis. Interestingly, so Ayer accepts the analytic-synthetic distinction proposed by Kant, but not its justification. For Ayer, a sentence is analytic based on its form, which is determined by the functions of the words rather than the containment of terms. For example, consider the example that Ayer presents. Some ants have established a system of slavery, and the other proposition, either some ends are parasitic or none are. We cannot determine whether A is true or false by examining the definitions of its constituent symbols, obviously. Instead, we must rely on observation. Thus, A is synthetic. In contrast, observation is unnecessary for establishing the truth value of B. I made again this point. So PAP, here are some somehow, I want to say some tenets that PAP endorses for his analysis. Sciences are the paradigm of genuine knowledge for empirical, somehow all logical empiricists. To understand where traditional metaphysics had gone wrong, the logical empiricists theorized the verificationist theory of meaning. Further, logical mathematical truths establish the meanings of our words by providing the rules governing the use of our language. And for logical empiricists, these meanings rules are conventional since their adaptation is not constrained by empirical reality. PAP sides with ordinary language philosophy by rejecting the idea that science represents the ultimate paradigm of knowledge and philosophical method. Still, he agrees with logical empiricists that necessity grounded in linguistic conventions shows the nonsense of metaphysical claims. In this sense, he is a logical empiricist, at least. The conventional features of our language are the rules that regulate the philosophical grammar, that regulate what is to make sense, talking about the truth underlying reality. For PAP, these rules express stipulations concerning the use of symbols and cannot significantly be said to be refuted by facts. In contrast, the sentences governed by these rules are empirically refutable statements about reality. Analytic truth, and here is the point of PAP when we will start discussing his arguments, analytic truths are problematic since a rule of language is neither true nor false, but defines what it means for something to be true or false. So semantic rules have a standard, serve as standards for thinking, which is conventional in nature and requires a priori agreement. Let's start from here, so necessity and analyticity. I think that this quote from Limbeck-Lillenau is very revealing. PAP develops arguments against the linguistic theory of necessity. That is, a position that all necessity is logical and that all a priori truths are analytic truths. Against this position, PAP defends a version of a synthetic a priori, which is not the Kantian version because Kant is very direct, offers a positive construction of synthetic a priori propositions, whereas PAP uses some negative criterion to say that analytic propositions do not somehow overlap the group of necessary propositions. Let's start by considering the relation between analyticity and necessity. Notable, PAP critique of the semantic notion of analyticity defended by logical empiricists, especially the idea that necessity can be reduced to analyticity altogether. For PAP, the two concepts greatly differ. The definition presented by Carnap, for instance, of analytic sentence as a sentence that is the consequence of any sentence, which makes the defined concept relative to a given language, is described in the following terms by PAP. The Carnapian definition makes the defined concept relative to a given language, that is P is analytic, must be regarded as elliptical, that is there is something missing in the definition, for P is analytic in L, since the syntactic consequence is defined in terms of the transformation rules for a given object language. Carnap's definition is primarily conceived for syntactical investigations into the formal structure of artificial languages, such as logical calculi and formalized arithmetic. However, analytic cannot mean necessary in the sense of syntactic concept. A syntactic concept is defined for sentences of an uninterpreted language. These sentences cannot be said to be true or false, since they are uninterpreted. But at best, if the system is complete, they can be said that they are derivable from primitive sentences or refutable based on primitive sentences. What exactly does PAP reject, though? He rejects the reduction of necessity to analytic sentences intended as semantic sentences. The necessity of propositions has always been meant as a semantic concept, a necessary condition which adequate analysis of necessary must satisfy is that the truth value of a necessary proposition does not depend on empirical facts. The reason for rejection, for these rejections are implicit in the Carnapian definition. First, the truth value of any analytic sentence is ultimately factual. This factuality conflicts with any requirement for necessity. Second, the truth value depends on syntactic rules of formation and transformation that precede every semantic concept. Indeed, the definition of Carnap of analytic in semantic terms yields a concept corresponding to an early defined syntactic concept in the sense that any sentence which is analytic in the syntactic sense, for instance, P or not P, where the logical constants, PAP talks about logical constants, but today we talk about connectives or logical operators, which is the same thing, or and not are not defined by truth tables, but occur as undefined logical symbols in the primitive sentences. Becomes analytic in the semantic sense once the language to which it belongs is semantically interpreted. Similarly, Quine defines an analytic statement as an abbreviated substitution instance of a logical principle. Let's, for instance, familiarize with that through the example that Xie is presenting. All sisters are female, P1 is all sisters are female, is necessarily true because it is analytic. That is true by definition. Specifically, since sister is defined as, that is synonymous with female sibling, and since the mutual substitution of synonymous expressions doesn't change the meaning of a sentence, P1 is synonymous with P2. All female siblings are female. The sentence P2 represents a substitution instance of a valid schema of first-order logic. In Quine's words, a logical principle. Therefore, it's logically true that for all x, f of x and s of x entails s of x. For Quine, a logical principle is defined as a true statement that contains only logical constants, once again connectives. For example, P3, which can be read as for every x, every f, every s, f of x and s of x implies s of x, as I told you before. However, the implicit existential determination of this latter is that something exists. That's the objection of PAP. Formalizable as there is an x and a p such that p of x expresses a logical truth that is problematic. The argument of PAP, the argument of this truth can be broken down as follows. The universal quantifier, okay, for all x, p of x is equivalent to, it's not the case that there is an x such that p of x does not hold. From the C1 equivalence, equivalent to, it certainly follows that the two statements of the form for all x, p of x, and for all x, p of x does not hold, are incompatible, not simultaneously true in a logical system, only if something exists. But why? And here is why. The statement for all x, p of x means for all x, p of x is true. That is universally quantified statement asserting that every element in the domain of a discourse has property p. The statement for all x's p of x does not hold, which I just translated, means that for all x not p of x is true, or for all x p of x is false. This is also a universally quantified statement, but it asserts that every element, that is the point of PAP, every element in the domain of discourse does not have a property. But what if this domain is empty? For those two statements to be incompatible, something must exist in the domain of discourse. If the domain of discourse were empty, nothing exists there, then both for all x p of x and for all x is not true, the p of x would be vacuously true. In an empty domain, there are no objects to satisfy or fail to satisfy the predicate p. Okay? Interestingly, we have something similar when we teach a logical tables of truth. If you see the conditional implication here, it's very weird that when p is false, and that means p doesn't exist and q exists, their implication is true. Why so? Because since there is no element, that remains undetermined. And for principle of charity, we say that it's true, doesn't matter what. If p doesn't exist and q doesn't exist, then p entails q. Of course, true. Wouldn't be paradoxical, says Pape, if it depends on extra logical facts whether two given propositions are incompatible by their own form. How can a logical constant be defined, by the way? A circular definition could be that logical constants are those symbols from definitions of which the truth of logical principles follows. However, this definition is unacceptable. And the problem remains since extra logical definitions unavoidably underpin logical constructions. A statement, says Pape, is analytic if it is a substitution instance of a logical principle, or in case defined, terms occur in it, a definitionally abbreviated substitution instance of a logical principle. This definition, though, commits us to acceptance of an interesting consequence, whether we like it or not. If a statement like no part of any surface is both blue and red at the same time contains undefined predicates blue and red, we cannot know it to be analytic unless replacement of all descriptive terms by appropriate variables leaves us with a principle of logic. That said, Pape wants to prove that substitution instances, although required, don't disprove two things. First, an analytic principle of logic might also be necessary in the sense that synthetic propositions may likewise be necessary. Synthetic propositions may likewise be necessary. That is a quite clear support of this Kantian synthetic a priori. Second, P is necessary doesn't entail P is analytic. The way in which Pape supports the synthetic a priori propositions of Kant is not direct, but indirect. He adopts Quine when Quine says if a proposition cannot be proved as analytic, it must be synthetic. And this is exactly what Pape wants to do. He doesn't like the expression synthetic a priori. He prefers to use the expression the material a priori, but means the same thing more or less for Pape. Although the converse entailment is undeniably true if a proposition is analytic, is necessary. But if a proposition is necessary, doesn't mean that it's analytic. Some sentences cannot be determined from their formula, even when the descriptive constants are replaced by variables, leading to a logical truth. Pape makes a couple of examples. The first one is not very lucky because actually the theorem he is talking about has been proved, so I skip that one. But the second example of Pape is luckier. The formula corresponding to no space-time region is both wholly red and wholly blue would be that is not the case that something that X exists and T exists and where X actually at the time T is P and X at the time T is Q, where surfaces constitute the range of X. As Pape argues, this formula is certainly not logically true, since we can easily find predicates which, when substituted for P and Q, would yield a false statement. So this claim must be truly examined. So we are talking about the second, we are entering the second part of this talk. I present a couple of instances of non-analytic Pop develops two main arguments to deny the reduction of all necessary or a priori statements to analytic statements. They pertain temporal statements and the color exclusion problem. Let's remind that the statement's property of being necessarily true, which is a variation of being more than simply true, can be clarified by analyzing it into two distinct properties, one pertaining the meaning of the sentence and the other one referring to its logical truth or the logical form. Pop really treasured this distinction and build on this. Temporal statements. On the one hand, Pop shares Lewis' view that analytic truth is grounded in certain immutable relations of objective meanings, not affected by accidental changes in linguistic rules. This is also his main objection to the linguistic theory of logical necessity. For Pop, the necessity of a proposition, whether the proposition be analytic or synthetic, is a fact altogether independent of linguistic conventions. But on the other hand, views like C.I. Lewis concerning the nature of analytic or a priori truths, where analytic and a priori are regarded as synonyms, are unsatisfying. Let's make an example like before, when we have for all x, f of x and s of x entails s of x. Pop argues that such an account of necessity fails to cover all truths which we intuitively recognize as necessary, as she says. So it only satisfies the condition that the necessity must be independent from empirical facts. Consider this statement. If A precedes B, then B doesn't precede A. As Pop comments, I assume that few would regard this statement as factual, that is such that it may be conceivably disconfirmed by observation. Still, it's not analytic either. To see this, we only need to formalize obtaining that for all x and for all y, x related to y entails that it's not the case that y is related to x. This statement is certainly no principle of logic nor deducible from logic. Hence, if we want nonetheless to call it necessary, it is non-factual, we had to admit that there are necessary propositions which are not analytic. As Xie clarifies, one of the main tenets of Pop is finding definition to demonstrate analyticity is that a definition, that's what Pop wants to point out. This is his tool for disproving the reduction of analytic statements to necessary statement. If a definition is selected only because it allows for the derivation from logic alone of the necessary to be established as analytic, then the analysis of necessity in terms of analyticity is circular. When faced with a reductive explanation of x in terms of y, Pop examines the basis on which we identify y's and finds that we do by recognizing x's. Pop's conclusion is then we have a primitive and irreducible capacity for intuitive knowledge of x's. Pop addresses now, the way in which he worked with that is a bit complex. So he starts with an objection. Those counter-arguments presented by Pop supports Pop's own theory. The counter-argument of Pop relies on the meaning of the concept x precedes y in logic. It generally indicates a relationship of order where x precedes y in a specified sequence or process where there is a general ordering, preference, temporal sequence, or causal dependency. Indeed, x precedes y can represent various relationships depending on the specific context. Although this ordering may not be strictly numeric and can be applied to different mathematical entities, depending on the context, Pop's view of x precedes y can be reduced, in all these cases, to an order set. I use Lipschutz for this. Let's just take a glance of these two examples of properties of relations. Suppose R is a relation on set S, satisfying the following three properties. These are properties of orders: reflexive, antisymmetric, and transitive. For any, in the case of reflexive, for any A that is an element of S, we have that A is related to A. If A is related to B and B is related to A, then we have that A is equal B, this is the antisymmetric property. And the reflex is very simple. If A is R related to B and B is R related to C, then A is R related to C. A relation R on a set S is called a partial ordering or a partial order of S if R is reflexive, antisymmetric, and transitive. A set S together with a partial ordering R is called a partial order set or poset. With this notation, the above three properties of partial order can also be considered for the case of PAP when A precedes B. The most familiar order relation, after all, called the usual order, is the relation of less than or equal on the positive integers P. More generally, on any subset of the real number R, these relations may hold. For this reason, a partial ordering relation is also frequently denoted by the preceding or the precedence symbols. Indeed, what PAP wants to say is that the same rules that hold for this kind of relation, less than or equal to, also apply to the relation of precedence. Indeed, as you can see from Lipschutz, who I'm sure he did not read PAP, so the same properties for an order set may explain also the precedence. So O1 is reflexive for any A that belongs to the set S. We have that A precedes A. Antisymmetric property, if A precedes B and B precedes A, then A is equal to B. And the transitive, if A precedes B and B precedes C, then A precedes C. There is a distinction between strict precedence and usual precedence. Strict precedes B, when we say that A strictly precedes B, we mean that A is an element of an order set, and that is S and the precedence operation, and B is not an element of the set. If it is not the case, then simply A precedes B. The objection PAP is trying to counter-argue is that if the statement for all X, all Y, X is R related to Y, implies that Y, that is not the case that Y is R related to X, is not factual, it doesn't mean that it's not synthetic either. As a general criterion for evaluating a sentence, we must reach its ultimately simple concepts, as Carnap suggests. If we apply this criterion to the relation of temporal succession, we obtain these simple concepts. Those compositions still result in a proposition that is true independently of empirical facts. It isn't disconfirmable by observations. Nonetheless, a non-factual necessary propositions may be synthetic, and that therefore analytic will not do as analyzance for necessary. A non-solution, let's see what non-solution could look like, would be the attempt to prove that the necessary proposition that I read before follows from logic alone. This attempt would beg the question at issue, since the attempt proof would require a definition of X precedes Y from which the asymmetry of this temporal relation could be formally deduced. But if this definition is considered adequate, then what is the criterion of adequacy here? A definition of X precedes Y, X py, symbol could be adequate only if it entails the asymmetry of P. That means that Y cannot precede X. Let's briefly recall that once again, what symmetrical means in logic and discrete mathematics. A relation is symmetric if it's identical with its converse, for instance, brother, otherwise it's asymmetric. An asymmetric relation excludes its converse, like father. The logical meaning of asymmetric slightly differs from the non-symmetric, which means also asymmetric and antisymmetric. It means that simply A is equal A. In discrete mathematics, a relation R on a set A is symmetric if whenever we have A related to B, then B related to A. That is, if whenever A and B are two elements of R, then BA are also elements of R. Whereas, on the contrary, in contrast, R is not symmetric if there exist A and B as elements of A, such that A and B are elements of R, but B and A are not elements of R. whereas antisymmetric property is simply a relation on the set R such that whenever we have A related to B and B related to A, then A is equal to B. I skip the details that follows. Therefore, the criterion of adequacy for temporal relations is the asymmetry, by means of which we can formally prove the relation X precedes X precedes Y. However, Popp argues that by enumerating all the formal properties which P must have, we couldn't construct a definition sufficiently specific to distinguish P from all formally similar relations with which it might be confused. More specifically, if I define P as asymmetrical, irreflexive, and transitive, the relation expressed by X is greater than Y as holding between real numbers will also satisfy the definition of X precedes P. I skip now because I'm running a bit out of time, so Fritz gave me 60 minutes, he's very strict on that. I'm very scared. So, but just to show you that what Popp is saying exactly what Lipschutz is saying here. The same set of properties define two different relationships. I cannot specify, given the properties alone, what kind of a relationship I'm talking about. A simple way to achieve uniqueness, that's what Popp wants us to consider to prove his point. A simple way to achieve uniqueness for the definition X precedes Y is to add the condition the field of P precedence consists of events. By means of this restriction, the necessary proposition that as Y, if A precedes B, then B doesn't precede A, is reduced to a substitution instance of the logical truth. X precedes Y and, X precedes Y entails that it is not the case that Y precedes X, and Q entails at this point that is not the case that Y precedes X, where X represents the remaining defining conditions for the use of P, is a condition for the use of P in this case. Obviously, Popp argues that the acceptance of the definition from which the asymmetry of temporal succession has thus been deduced presupposes the acceptance of the very proposition temporal succession is asymmetrical as self-evident. This definition is circular and reveals the fallacy of an argument that assumes that the very thing it is trying to prove is already true. This way of proving that the debated proposition, in spite of superficial appearances, analytic, is therefore grossly circular. Now we move to the color exclusion problem, which presents a couple of instances. It's another example of non-analytic necessary proposition that Popp wants to show. A second argument pertains to the color exclusion problem, which derives from the statement no space-time region is both wholly blue and wholly red. Is a necessary sentence, but there is no ground for saying it's also analytic. Popp examines the related sentences. Nothing can be simultaneously blue and red all over, and whatever is colored is extended. He intends to prove that the statement is not the case, that there exists an X and there exists a time such that X is blue at the time and X is red at the time is not a logical deduction. Indeed, if blue and red designate unanalyzable qualities, it is difficult to see how analysis could ever reveal that this statement is a substitution instance of a logical truth. Popp reads the same statement by identifying the type of entities to which colors may apply. These entities are clearly surfaces, no matter whether they may be located in physical or perceptual space. Popp defends the following argument. If I say X is blue at t and also Y is red at t, where the values of the variables X and Y are names of surfaces, I have already implicitly asserted that X is different from Y. In the same way as simultaneous occupancy of different places is tacitly regarded as a criterion of the presence of different things at those places. These kinds of arguments are circular. That's the goal of PAP. If we formalize the proposition above, we obtain the following one for all x, all y, and for all times if x is blue at t and y is red at t, then x differs from y, which is somehow, which implies also the second statement, like call it the second statement S, we call the first statement T. It's not the case that there exists an X and there exists a time such that X is blue at the time and X is red at the time. It follows that S derives from T, hence we may mistakenly say that if T, then S is analytic. However, this is the counter-arguments of PAP. We could first have to prove that T is analytic before we could assert that S is analytic. As I follow the rule, says PAP, any proposition is to be held synthetic unless it is derivable from logic alone. That's interesting. I hold that T to be synthetic until such time as conclusive proof of the contrary is produced. For PAP, the only meaning we can attach to the statement non-blue is part of the meaning of red is just that X is red at T entails that X is not blue at T. And the question at issue is just whether such an entailment may be regarded as analytic or formal. Surely, not blue could not be an element of the concept red in the sense in which male is an element of the concept father. Similarly, if X is colored, then X is extended, presents the same issue. The involved predicates cannot be analyzed in such a way as to transform the propositions into tautologies. The question remains, why is this particular argument not considered analytic by PAP? What's the reason for that? Below is the explanation of analyticity, which we should all agree. If we stipulate that only names or description of surfaces are admissible values of X in this universal statement, then each substitution instance of X must be analytic as well, since it has the form, if this surface is colored, then it is a surface, which is reducible to, says PAP, if this is a surface and color, then it is a surface by logical simplification. Therefore, the universal statement itself, which may be interpreted as the logical product of all its substitution instances, may be analytic by default. PAP argues that this argument begs the question. The statement, only surfaces can significantly be said to have a color, differs in an important respect from statements like only animals, including human beings, can significantly be called fathers. The latter involves analyzable predicates that could be replaced by the statements fathers are defined as subclass of human beings. At the same time, we cannot assume without begging the very question at issue that X is colored entails by definition X is a surface. About the color exclusion, now we talk about the second argument, and it's give me other 10 minutes and it's the end of my talk. So the second argument to support the thesis that a necessary proposition like if X is colored then X is extended is analytic is stated as follows. If we analyze X is colored, we could deduce the consequent from the antecedent and see an analytic connection holding between them. PAP's strategy is refined. He doesn't deny that the analytic character of the connection. His purpose remains to argue, nonetheless, that there are necessary propositions, that is, propositions which are known to be true independently of empirical observation, which are not known to be analytic. Therefore, PAP rejects the statement, this is just a sort of recap, the statement of a logical empiricist that all necessary propositions are known to be analytic. This standard argument for analyticity implicitly assumes an initial condition, a stipulation that, according to PAP, compromises its validity. Indeed, if we stipulate in advance that an analysis of the antecedent will be correct only if it enables deduction of the consequent, it is not surprising that any correct analysis of the concept in question will reveal the analytic nature of the statement. In Papp's own words, if x equal y, then y equal x is necessary. Quite independently of our knowledge of logic, one feels that it would be self-contradictory to deny any substitution instance thereof. Once we have established the rule, all substitution instances must satisfy the truth values of the schema. But as long as the relation of identity of individuals remains unanalyzed, there is no way of deducing it from logic. If x is R related to y, then y is R related to x is not true by its form. That's the main statement of Papp. And now he presents this argument. It's super interesting in my eyes. Thus concludes Papp, nobody would be perfectly safe in claiming that this proposition, if x is related to y, then y is related to x, will turn out to be analytic once the involved relation is correctly analyzed. Do you remember the symmetric property of relations we just saw? R is symmetric if and only if, for every x and y, if x is related to y, then y is related to x. That is, for all x, all y's, x are y entails y are x, and R is asymmetric if and only if, for every x and y, if x is R related to y, then it's not the case that y is R related to x. However, nothing in the logical form of x related to y contains the implication that y is related to x, or it's not the case that y is related to x. The unanalyzed propositions for all x, red x entails not the case that x is blue, is obviously not a logical truth. It can only be shown to be analytic if we can give an adequate analysis of its descriptive color terms. That's from Christoph. As Limbeck-Lillenau reminds us, in this context, Papp adopts Quine's conception of analyticity. A proposition is analytic if its truth is based on logical science alone, if it is the case for logical truths such as tautologies or the laws of logic, which are true independently of the meaning of their non-logical terms. A proposition is analytic if, via analysis of its descriptive terms, the proposition can be transformed into logical truth. For instance, the classic case, all bachelors are unmarried, can be transformed to a logical truth if all unmarried men are unmarried by analyzing bachelor as unmarried man and substituting the former with the latter. I skip this because this can be skipped. The same issue, I'm almost at the end, the same issue recurs in Wittgenstein's Tractatus, where although color concepts are treated as unanalyzable, red nonetheless entails non-blue. An additional difficulty arises from Wittgenstein's assumption that elementary propositions are logically independent of one another. So, if the terms red cannot be analyzed further, then x is red is an elementary proposition, and as such, it excludes other elementary propositions, such as x is blue or x is not blue. If we use the standard truth tables, this is the point of Papp. When we use the standard truth tables, where every line designates one possible state of the world, we encounter impossible combinations. Consider, for instance, this example. Let's P be A is red and Q be A is blue, where A designates the same spatiotemporal area. The distribution of truth values for P and Q shows that their coexistence is possible, namely true. So here you see the conjunction, once again, the truth tables, you see the conjunction that you have when you have P is true and Q is true. We know that this is the only case in which the conjunction gives you the outcome of true, okay? But here is the interesting thing. So if P stands for A is red and Q stands for A is blue, and we may introduce the restriction at the same time, we have that P is red and P and Q at the same time is true. And simultaneously, that shows also that when we say that A is red And is not the case, then A is blue, guess what? The conjunction is false, and the other way around. It's impossible, however, for P and Q to be both be true for when P, I don't read this because I just explained to you in a very, very simple terms. Our logic allows us to say that A is red and A is blue at the same time, but a more complete logic should exclude this. This is a conclusion I share with Limbeck-Lille now. Papp concludes that the statement for all x when x is red entails that is not the case that x is blue is necessary without being a tautology. Therefore, its necessity is a priori, but isn't analytic. I'd like to conclude now with a very beautiful passage of Papp that somehow summarizes everything I have tried to convey in this lecture. It is my contention that that even a formal statement, as it would commonly be called, like for any x and y, if x is equal to y, then y is equal to x, is a synthetic a priori truth. This would indeed amount to going more Kantian than Kant himself. For on the same principle, it could be argued that all logical truths, which Kant at least concede to be analytic, are synthetic. Kant indeed thought of them, of logical principle, as analytic principles, not synthetic, but Papp seems to go in this direction. Take, for example, the commutative law for logical conjunction just mentioned. Obviously, I cannot prove that P and Q is equivalent to Q and P is tautologous unless I first construct inadequate truth tables defining the use of and. Surely, one of the criteria of adequacy for such a truth table definition consists in the possibility of deriving the commutative law as a tautology. If, for example, a T were conventionally associated with P and Q, then the combination FT holds, and an F, when the combination TF holds, the resulting definition will be rejected as inadequate just because it would entail that the commutative law is not a tautology. For Papp, all these logical implications that we learn in logic and even in laws of discrete mathematics, so the 18 rules of natural deduction, 8 rules of implication, 10 rules of replacement, are all instances of synthetic a priori or materia a priori. Many thanks.